Very pleased to welcome Andrew Purvis from worldsteel, who is joining the podcast today to talk a little bit about the approach that the steel sector can take and is taking to decarbonisation. Andrew, would you mind kicking off, just give a bit of background, both to you in the steel sector, but also you in this decarbonisation debate? Where are you coming at this from?
Hi, Alex. Thank you. Thanks for having me on. I'm Andy Purvis. I'm currently Director, Safety, Environment, Technology with the World Steel Association. For anybody who doesn't know World Steel, we are the international trade body for the iron and steel sector. So our members would be steel companies. And probably if you can think of a steel company you've heard of, they're probably one of our members. The vast majority of global steelmaker would be members of World Steel. In terms of where I come from, I've worked in the steel industry a long time. I started maybe nearly 25 years ago now. Before I went to university, I spent a year with British Steel, the old British Steel. And after university, I came back to the research division. So I spent really most of my career in the steel sector in the Netherlands, in the UK. I spent 5 years in Australia working in climate there for an Australian steel company. And I'm now back in Europe in World Steel, where I live in Brussels. So I think for our sector, climate change it's clearly a big issue. It's one of those mega trends which is increasingly impacting what we do, what we talk about, and what stakeholders, members, and indeed customers want to talk to us about. It's really, I think, one of the key issues for our sector to manage at the moment.
Out of interest, when do you think that conversation shifted? When do you think you started to sense that there was a real shift, that the industry as a whole was really getting on board with not just the need for it, but the want of it, the wanting to pursue decarbonisation?
I think decarbonisation as a topic has been talked about for quite a long time. I think back to when I was in research in the Netherlands in the early 2000s. It was when the Ulcos project was kicking off in Europe, and that was a project to dramatically reduce emissions from the iron making process. But I think it's fair to say that there has been an increase in interest in what is generally described as hard to abate sectors. And I kind of line that up, I think, with the Paris Agreement. I think after the Paris Agreement, my feeling is there's been a general shift in perception. I also think it's generally understood that the power sector, it's understood how the power sector can be decarbonized. There's a lot of discussion about renewables, CCS. It can be done technically. There's a lot of discussions to be had about how you do that and how you do that economically and infrastructure and so forth. And attention has maybe shifted a little bit to those hard to abate sectors where decarbonization is more difficult. And steel is one of those because the emissions from our sector are largely a result of the chemical reduction of iron ore into metallic iron. And it's very difficult using existing technology to abate those. You can't just swap to windmills or solar or renewable energy. So I'd probably nail that down to around the time the Paris Agreement was signed. And since then, we've definitely seen a lot more interest in our sector, a lot more external projects and initiatives looking at our sector. And an example of that is the IEA roadmap. The International Energy Agency released a roadmap earlier this year, which set out how our sector fits with their sustainable development scenario, which I think leads towards total energy system decarbonisation by around 2070. So there's definitely an increase in interest in the steel sector.
So I know one of the things that World Steel has been working on is this idea of a kind of a 3-track approach to how the sector can decarbonise. Let's start there. What are the headlines of that? And then hopefully what we can then have a look at is some of the practical implications of it, because I think that is obviously where for many hard to abate sectors, the real gritty challenge lies is first that a roadmap or a pathway or something that feels realistic and something they can get their hands on. But then translating that into action is obviously the next challenge. But let's start with this 3-track approach that World Steel is advocating for. And what does it mean? What would a steel company need to do if they were pursuing that?
I think one of the things we really need to think about when we think about steel is the scale of the sector. We made globally around about 1.8 billion tons of steel last year. So if the industry was like, you could imagine the industry is a bit like an oil tanker. It's going to take a long time to change radically. So one of the concepts World Steel has been floating and promoting is really looking at this decarbonisation and emissions reduction story in three distinct phases. The first of which is really what can we do right now? Well, what we can do right now is make sure that every ton of steel that is manufactured with the minimum environmental and climate change impact as we can. One of the benefits of World Steel is we have a very broad membership, and we've been asking our members to report on their emissions for 15 years or so. So we have a big representative data set covering the world's steelmaking capacity. We also have sitting behind that other benchmarking systems that cover issues such as yield, you know, maintenance, operations, and these kind of topics as well. And where we are now is we're suggesting that as I said, every ton needs to be the most efficient ton. And some of our members, like in any normal distribution, are better than others. So the challenge we've set the industry through something we're calling Step Up um, is really to encourage and support all of our industry to operate at levels of greenhouse efficiency that are sort of commensurate with the best performers. And that's really about assisting our members in understanding the opportunities they've got to reduce their emissions and improve their operational efficiency. This is through how they use their plants, how they operate their plants, the choices they make in terms of purchases and raw material purchases. All of these things can impact the final greenhouse intensity of steel that's produced. And we have this really rich data set, and we can work with our members, and we are working with our members to support them in reducing their emissions. This will help, clearly, but at the same time, when you're facing total decarbonisation of the energy system by mid to late century, it's not going to be enough. The second element of our strategy would be around the use of scrap and scrap steel. It sounds like a waste material, but actually, scrap is a fundamental raw material in the steelmaking process. All steel plants melt scrap. It varies. So there are steel plants that use electricity to melt 100% scrap. But even the blast furnace steel plants that use coal or gas and iron ore to make new steel or virgin iron also use up to 15% scrap. In fact, you need it as a coolant within the process. And scrap's been very beneficial from a greenhouse perspective because every ton of scrap that you're able to use saves around about, on average, 1.5 tons of CO2 being emitted. So logically, you want to use as much scrap as possible, and that happens. So all the scrap that's available is used within the steelmaking sector. Now, the reason we can't use 100% scrap is that the demand for the material, which is predicted to increase, but not least because all of the decarbonisation technologies are fairly steel intensive. The issue is the demand for steel exceeds that we are able to make with scrap, but we should and do use as much scrap as possible. Now, after the millennium, there was a huge increase in steelmaking production. And we see that. And it largely came out of China. It was a huge exponential increase over the first few decades of the 2000s. Scrap generally stays in use for an average, a lifetime. And that varies by application. For buildings, it might be 50, 60 years. For packaging, it may be a few months. And the average is probably around 15, 20 years or thereabouts. So what we're going to start to see over the course of the next 10 to 15 years is this scrap that will be entering into the scrap market, the steel that was manufactured in the first few years of the century. the first 20 years, say, of this century. So we're going to see an increase in scrap. And that's really going to help because that means we can use more of that, and that will allow us to reduce emissions from virgin steelmaking versus uh, which would have been the case. But again, that's not enough to solve the problem in the long term. It certainly will depress emissions from the sector. It will buy us the time that we need to develop breakthrough technologies. And that's the ultimate end point, will be to radically change the way we turn iron ore rocks into metallic iron. Right now, that happens in two ways. It happens in the blast furnace, and we use coal and coke, and that generates greenhouse gas emissions. And it happens in something called direct reduction of iron. That generally happens with gas, lower emissions, but emissions nonetheless. And if we're heading for carbon neutrality, increasingly we can't have those kind of emissions. Now, as I touched on, this is approaching a 2 billion ton industry, and it's going to take time. So having these three steps working together will buy us time to get this radical breakthrough technology developed and deployed globally. I think it's also worth maybe reflecting on the types of technology, because there isn't a silver bullet for iron making in terms of how we'll make iron in the future. There's been a lot of talk about hydrogen. I'm sure a lot of your listeners will have seen that, particularly in Europe. But there will be different technologies that will work in different places. And I think the degree of take up of hydrogen, steelmaking, carbon capture, storage, CCUS, and ultimately potentially using technologies such as electrolysis, direct electrolysis, which is how we make primary aluminium now. It's never been done in iron making. I think they've made kilograms of iron and steel using direct electrolysis. As I said, it's a 2 billion ton industry. But it may be that as we get towards the end of the century, that kind of technology will play a part. But I think in specific regions and countries, the technology that will work there will be determined by lots of local conditions.
That's been one of the interesting things for me across the hard to abate sectors, because coming at it from the outside, you make a lot of assumptions, don't you? And you sort of assume that cement is cement is cement, and steel is steel is steel, and why would making it in Egypt or somewhere, make a difference? But there are geographical and geological and all sorts of other differences, and that's the same from what you're saying for steel as well.
Yeah, I think so. I mean, it's interesting to look at, just as examples where we're seeing these pilot developments now. This in Sweden, and indeed in Hamburg and Austria, they've been looking at hydrogen reduction. And why is that? Well, that works. The conditions are right for that in some parts of Europe. In Sweden, they have lots of renewable electricity. There's a partnership with a miner, fairly strict targets that the government have set, and the partnership is there. In other places, whether it's within Europe or further afield, there may be conditions that suit other technologies. Around the North Sea in Europe, we see potential for CCS. Certainly in China, there's been work done looking at CCS. There's DRI, which is manufactured in the US, increasingly with natural gas. And the location of that could well be suited for CCS as well in the near future. So I think there'll be a wide variety of technologies, and they will be deployed really very much depending on the conditions and the support which deployment gets from government.
Those three areas that you've talked about, then, that the kind of every ton to be an efficient ton, the kind of increasing use of scrap or how to increase the use of scrap, and then breakthrough technologies, that kind of broad cluster of new technologies. How, when you sort of think about your getting to net zero, getting to carbon neutrality, what's the weighting between those three channels of activity? Where do you expect to see the most gain? And where's the easy? Well, I guess the easiest gain you'll no doubt say is around efficiency, but maybe I shouldn't speak for you. Tell me a bit about what's the weighting of those three channels in terms of achieving net zero.
It changes very much, Alex, by time. If you look at the first phase, let's say between now and 2030, I think IEA, when they looked in their roadmap, they determined that the really most significant impact is going to come from process efficiency and material efficiency in that time. And that kind of makes sense. And that fits with the timeline I had in my mind. Beyond that, you'll start to see the scrap entering the market, and the long-term breakthrough technology. My take is you'll start to, we expect to see low carbon, low CO2 emission steel coming onto the market by the mid 2020s, maybe to 2030. But it'll be beyond that when we really see increases in volume of really breakthrough technology making steel that's coming onto the market. And for that to happen, of course, there needs to be a market for that material. I think that's really one of the key points, because making low carbon steel or low emission steel is very doable technically, and we're starting to see that. But it will cost more than steel made using conventional technology. And there's going to be a time when those two approaches are competing in the market.
If you take it from the consumer perspective, let's say I'm buying a steel-based product, what sort of price difference might I see as the end consumer of that versus, obviously any increase in cost, affects those intermediate players more. But what's the reality of that cost change to the end consumer?
It's difficult to say for the consumer. I think it's fair to say that if you make, from our perspective, making low carbon steel will cost, I think IEA estimated it up to 120% more than it does now. So that, it's more than the margins. Clearly, when you look at something like a car or a building, the proportion of the cost of that whole package, which is due to the material, is lower than just looking at the cost of a ton of steel. But the margins matter for steel producers because this low carbon technology needs to be investable. So we need to create conditions by which steel companies can transition to radically different technologies and at the same time be able to recoup on those investments. So having that market is important. And I think there's a reality that low carbon CO2 steel will come at an additional cost. And ultimately, stakeholders and users of steel will see that and need to see that.
From what you're saying, that those we've got those timelines of now to 2030. It's more about efficiency, process, and materials. Then we see that kind of the bigger explosion of scrap coming back that can be reused, and then of course that kind of wave of new technologies. So right now, the issue I imagine is partly for many companies that their own individual strategy, but also how it's financed. So are your members seeing availability of investment? So are there partners out in the market who are at least talking about investing in these big projects, or what are you hearing about that? Because that's obviously going to be a big part of this equation.
Yes, I mean, indeed, access to finance to enable this transition is going to be very important. And I think it's healthy that there's discussions happening now around such topics as sustainable finance and green finance about how you make this possible. But my feeling is ultimately you need a market. We need a market for low carbon steel. We need this premium product to be able to attract premium prices. And there's a number of ways that can happen. I think in the short term, there will certainly be a role for government, and governments can help in a number of ways. It's about not picking winners. It's about ensuring that governments can play roles through, for example, procurement. They can look at issues like contracts for difference when they're buying steel themselves. But I think another big important issue is infrastructure, because a lot of these low carbon technologies will require hydrogen, for example. Hydrogen needs to be generated at very large volumes and distributed to where it needs to be. If you look at CCS, if that takes off, I think you can reasonably expect steel companies and many industrials to look at capture, what they can do within their own sites. But in terms of infrastructure to take that CO2 and store it and develop the stores, all of that will need, I think, a strong government hand. And I think there's a really important role for governments to play in putting the conditions in place that will allow this transition to happen.
We're definitely seeing across Europe and in the States, money and policy landscape that seems in part geared to supporting it. But a lot of that money, and do correct me if I'm wrong, but a lot of that money has gone to sort of early stage technology development rather than big infrastructure plays so far. Would you say that's fair?
I mean, I think it's fair to say that you have to get the fundamentals right. And when you're looking at these really radical breakthrough technologies, you're going to see more. I mean, governments are very comfortable supporting research. That's something that's happened for a long time. But we will need to see a change because clearly the costs associated with research versus actual deployment are very different. So I think that's probably been appropriate. But as we move away from lab and first demonstration to actual industrial scale deployment, it's an entirely different challenge for governments.
I know there's another strand to the kind of the work and the encouragement that World Steel is giving to members, which is around the kind of new types or new is it advanced products. I think that was one of the phrases I was reading about. So the products that can be made that also enable a transition. So not just making those products in a way that is cleaner and decarbonized, but also creating products that in themselves drive transformation. Can you give me a little bit of an insider's view on what that means?
I mean, it's a bit like three phases on three phases, but what I've talked about with us today, what we've talked about today is being what we can do as an industry and what we need to do and what we will do to reduce our own impact. And that's very important. But at the same time, society will need steel. And the steel industry, I think, has a role to play in developing and manufacturing the advanced steel products that increasingly society is going to rely on to reach carbon neutrality. And you could think of different examples of that. Electrification is clearly going to grow as we go forward, whether it's in automotive, in many heat, in many sectors, and that needs electrical steel to allow that to happen. And we need to generate a lot more electricity. And again, generation of low carbon electricity is fairly steel intensive as well, whether it's through CCS or renewables. So I think the steel industry has an important role to play in developing new, stronger, lightweight, and targeted products which can be used to enable the industrial transformation that the transformation that society needs to go through. And the other piece, of course, is that the circular economy, which has been talked about a lot over the course of the last 5 to 10 years. And steel is actually a great fit for the circular economy. The circular economy is about reuse, remanufacturing, and recycling fundamentally. We've talked about recycling. Steel's well suited for that. It's got properties which mean it can be easily collected. It's magnetic, and you can turn anything into anything else. But it's also very well suited for reuse and remanufacturing. So if you look at buildings, there's great examples of steel being reused. In fact, we've seen whole structures, bridges which have been relocated, and building structures which have been rebuilt. So I think the material itself has got a strong role to play as we go forward through transforming society to mid and beyond that. But we have to get our own house in order, and that's almost a hygiene factor to be part of the solution. And I'm confident we can do that.
On circular economy, the other aspect of that, which is obviously more complicated, I think, for many companies to start the ball rolling on, is it's also about potentially changing business models as well, isn't it? So I know I was speaking with someone from one of the UK steel companies who was explaining this idea of the circular economy is not just that one point in time when you're exchanging value, but really looking at steel as service, or something similar to that. Are you seeing many discussions about the business models versus? I mean, I know the recycling portion of that is incredibly important, but are you hearing your members talk about the kind of potential for different business models to emerge?
I think the industry has always transformed and evolved, and it's no different now. In fact, potentially, I mean, you could argue it's our industry as well as the rest of society is changing more quickly than ever. As long as I've been in the industry, there's been discussion of companies leasing steel to customers as a service and using that and it coming back at the end of life. That's something that has not really taken off, and it'll be interesting to see if that happens. It's certainly being talked about. The other, key change which we're seeing is around automation, and that's again one of the key mega trends that we see impacting our industry, and particularly the growth of artificial intelligence and smart materials. And that goes to the smart factory, how we make steel, but also the use of those steel materials in use. And you could look at, transport and how the sharing economy and potential ride sharing and shared mobility will completely transform the way we look at the automotive sector. And you're seeing net zero buildings and real changes in the construction sector. I think it's an exciting time. I mean, it's scary if you're used to the way things always used to be. But I'm kind of confident our industry and our members can react and really seize the opportunities that are going to be offered.
So if, as is often the case when any big transformation is getting going, it's somewhat transactional in the early stage, isn't it? Like your members need something from the outside world, and the outside world needs to see movement from your members, and it's kind of this thing that has to happen at the same time. So if you were going to, just as a kind of a closing question to you, what is it that the steel sector needs? Like, we were going to say, I'm pressing this button to accelerate decarbonisation. What's the button? What is it that they need?
I think, at the risk of repeating myself, we need a market. We need a market for this low carbon steel or low emission steel, and people who are willing to buy that and accept that it's going to cost more to do things differently, and it's going to cost more to make low carbon materials versus how things used to be. Um, our members are very good at acting in the market. The steel industry is very competitive, healthy. It's a healthy competition amongst all of our members, and I feel confident that if the market conditions are in place to allow that fair competition, we will see change.
And then if we sort of flip that around, if you imagine you're in one of your member meetings, or this kind of cloud of members around you, what is it that you're saying, come on, let's show this? Like, what do you think the sector can be doing in the next 2 to 5 years that can really show movement from within, rather, because obviously those external factors that you're talking about are they are essential and they are needed. But what are you saying to members? Come on, let's prove this point. What do you expect to see from them?
I think we need to really step up our efforts as an industry to improve this efficiency, this first step across our global industry, and work with partners and neighbors to create industrial synergies. There's a lot of potential overlap between our industry and others, and I think the more partnerships that we can develop would be very helpful. We need the breakthrough technologies. We need to invest in those breakthrough technologies to prove that they will work, and we're seeing that. I mean, if you look across the world now, I think in all regions there are companies spending a lot of their own money on developing radical new technology. We see the hydrogen smelting in Europe. Tata Steel, an Indian member of ours, is spending a lot of money developing something called Hisana, which is around a really radical smelting technology, which is very well suited for CCS. We're seeing members in China looking at CCS and hydrogen also. So we are seeing that, and we need to encourage that, and we need to continue those investments so we are ready when the time is right to deploy those technologies into the market.
Okay, well, thank you. Really appreciate you giving us some time. I know a bit of a crack record when I wrap up these podcasts, because I know you always say there are no easy answers, but there aren't. It definitely, that need for the market to show itself that, yes, the government procurement system will kind of step up to greener products through their big infrastructure projects and things like that. It's real. But equally, the consumers, of which I am one, we also need to show that we will pay more for those things until we get to that point of real cost effectiveness coming through with volume of scale and so forth. But thank you very much for walking us through that. Thank you.
My pleasure.